So far in our microservice architecture, you've seen that we've used RabbitMQ right here so that if notification is down, for example, our application doesn't crash. Also, we can send asynchronous notifications, and we get a lot of benefits by introducing a message queue. So we've used RabbitMQ, but what I want to show you is how we're going to use Kafka. And because you understand how RabbitMQ works, then Kafka should be really straightforward. So if you look at the use cases for Kafka, on their website, they say messaging. So Kafka works well as a replacement for a more traditional message broker, i.e. RabbitMQ or others, right? So message brokers are used for a variety of reasons to decouple processing from data producers to buffer and processed message, etc. In comparison to most messaging systems, Kafka has a better throughput, built-in partitioning, replication, and fault tolerance, which makes it a good solution for large-scale message processing applications. And really, they're referring to ActiveMQ or RabbitMQ. So this is exactly what we want, right? So we want a messaging system. So let's dive deep into Kafka. So by now you should know how all of this works, but let's first set up our broker in here. So I said Kafka runs as a cluster. That's why we have n brokers. Now a broker is just a VM, a machine or a VM which runs the Kafka process. You can have two or more, but there's no limits to how many brokers you can have. And usually some companies, they have thousands of these up and running. So a broker is just a machine or a VM running somewhere in the cloud maybe, or in premises, and it just runs the Kafka process. It manages all the partitions for us, the read and write requests, and a bunch more. Let's go ahead and set up a Kafka broker locally. In here, I'm within the official page for Kafka, which is kafka.apache.org. And you can see that they gave a brief description of what Kafka is and some of the industries that use Kafka. And if I scroll down, you can see that it's basically high throughput, scalable, permanent storage, and high availability. So it stretches clusters efficiently over availability zones or connect separate clusters across geographic regions, which is really nice. And you can see the ecosystem in here. So built-in stream processing, connect almost anything, a bunch of client libraries, as well as large ecosystem open source tools. So let's go ahead and in here navigate to get started and quick start. Within this quick start page, you can find this video that explains what Kafka is. But if I scroll down, have a look, we've got a couple of steps in order for us to get up and running with Kafka locally. So in here, I want to download the latest release. So let's just download. And within this website, have a look at this HTTP link. Let's just click on it. And then I'm going to save this into my downloads folder. And if I go back to the previous website, and now you can see that it says CD into that folder. And then we need to basically start the Kafka environment. So here we need to basically start Zookeeper. So this is where Kafka stores all of its configuration. And then we can start the Kafka broker. So let's just take this command in here, Command C, go back, and here I'm going to CD into Kafka. And now I'm going to paste this command. So this will basically start Zookeeper. There we go. And you can see that it's up and running. Now I'm going to open up a new shell. So Shift Command D, CD into downloads. And next, what we need to do is to start the broker. So here, take this command, and basically it's just invoking the sh file. So back in the terminal, I need to CD into Kafka and paste that command, enter, and there we go. So you can see that from now on, use broker on localhost 9092. So we have Kafka up and running, which is really awesome. Next, let's go ahead and build our Spring Boot application that will send messages to a given topic.